Well, thank you. Well, thanks so much for coming. I hope you enjoyed Richard's space talk. I've seen that a couple of times, and it's amazing. You've probably filled the day so far with talks about amazing code and techniques and things like that. But I want to start my session today with a quick question: is there more to life than just the code? And I can see I've already lost most of you. But my point is that we love code as developers. We love new languages and new frameworks and new syntactic sugar and all that kind of stuff that comes out. We love ingenious architectures and elegant algorithms. We argue about frameworks and formatting and the correct number of indents for indentation, which is 2. We pretend to understand recursion. We argue about comments and dark mode and all this kind of stuff. We're really into writing the actual code. And look, I love code. I do. I will sit down. And write code. I'm going to stick towards the back of the stage, maybe. I love writing new code. I love these new language features. I saw an amazing C# talk at the last conference I was at that made me realize that I really miss writing code. But I have been kind of peripheral to the code for quite a while now. And as much as I can look at code and love it, here, look at this as an example. This is C# code. It's a C# class. This is pretty typical, right? But languages get better, and we get great new features, and we all get excited. So one thing I learned in this great .NET talk that I saw at the last conference was about this thing called primary constructors. So this is the code that I would be familiar with writing, right? These days, primary constructors mean you can do that, and it's the same, which is beautiful, isn't it? You can replace all of that boilerplate with this, which is if you can do that now, you can save seconds every project, right? And then ultimately, it compiles down to the same code when it runs anyway, because it's just syntactic sugar. And then, honestly, if you use any one of the AI tools, then you probably don't have to write most of that anyway. And just to prove that, look, this is how I actually wrote that code. So I just put a comment at the top saying customer class with a constructor, properties, and some other stuff. And age and a say hello method, and then I waited for a second and typed public, and then it went boom, and I hit tab and I was done. So those seconds that I saved with primary constructors didn't save them anymore, right? So code might be important and it might be great, it's beautiful, but what I want to stress today is that writing the actual code and the actual code itself is just a really small part of what is involved in delivering useful software to customers. Moreover, I want to point out that the destructive power of inefficient code pales in comparison to the destructive power of so much other stuff that happens in your workplaces. Right? So today we're going to talk about some of those things that can ruin projects and improve the performance of your projects and the software delivery that happens, being able to get something useful into the hands of your customers. So we're going to talk about that today. I remember having a job interview when I first started writing code 26 years ago, or when I first got my first job. And they asked me to write an algorithm on a whiteboard, of course, to sort a list. Does anyone know what the correct answer to this is these days? If somebody asks you to write code to sort a list, it's this. That's the right answer, right? Because, and I hate to say it, the compiler is way better at writing code than you are. Somebody has optimized that way better than you can optimize it. If you spend all your time writing a better list sorting algorithm, total waste of time. Even if you write the most elegant, beautiful, fast, performant code to sort a list, it's probably going to run in roughly the same time for your 100,000 records that you're sorting over. Right? Computers are fast these days. They're fast enough to make up for horribly inefficient code. There are exceptions, of course, but I would guess most people here are writing forms over data, essentially. People fill in a form, the data gets saved, and then there's ways of displaying that data and editing that data. Writing a faster sort algorithm is probably not going to earn you much, and it's going to waste a lot of time. Now, it wasn't always like this, right? There was a history in software development where being able to write really good, elegant, performant code was incredibly important. So everybody's probably seen a picture like this, which is a punch card or a punched card. And people have been writing code in one form or another since the early 1950s. I know you've seen this before, but I want you to really look at it this time. So what would happen is programmers would write really low-level instructions on coding sheets. So they wouldn't punch them straight into cards, because that's just deploying straight to production. You would write them on little coding sheets, and when I say low-level, by the way, I'm talking about store a value in a register, read a value from a register, and then multiply them together, and that's your entire set of instructions that you can use. So you have to use it. You have to write code that does something useful based on that. Then they would go and they would line up where somebody would punch holes in the cards to represent the little bits of these instructions. Write something to this register and read something from that register. Then you would rent time, often at great expense, to one of a handful of computers that was able to read these punch cards and do stuff with it. You would run through all those punch cards, hoping you didn't drop any on the way, because if these got out of order, you'd start again. And then you would hope that you didn't make any mistakes at all the whole way through. Otherwise, you have to run it all again, do the whole thing again, right? So back then, think about how much value there was in getting your code to be a little bit more efficient, a little bit more readable, and, well, not terribly readable, I guess, but, more efficient, better code. There was a huge amount of value. If you could write something faster and better than the person next to you, the developer next to you, you were way more valuable, right? Your value was a lot higher. These days, we have it easy. And there's a pattern that happens with all technology, right? And this is technology in the broader sense. Over time, it gets easier and easier to use, right? So humans gain more and more collective knowledge. We build tooling that's better. We add layers of abstraction. And at some point, we really forget how hard it used to be, which is fine to an extent. But if you compare that punch card example with the current state of the art for writing software, which is, as everyone knows, writing some stuff to ask ChatGPT to write the code for you, and then you paste it into your thing and you commit and push it without reading it. That's the current state of the art. It gets deployed out to production on servers that are managed by trillion-dollar companies that you pay 4 cents a week for. It's so much easier than it used to be. So in this environment where you can do this stuff so quickly for so little cost, the value of being able to write beautiful, elegant code that's a little bit faster, a little bit more performant, it's not zero, but it's getting closer, right? So then what does this mean for us as developers? If that's our job, is to write code, what does that mean? Where do we get our value from? So in the late 2000s, thanks to people like Patrick Dubois and Andrew Schaefer, we were introduced to this concept called DevOps. The idea was that we had got so good at writing the actual code that bit was no longer the hard bit. Our people, our processes, our tools, and things like that, the whole infrastructure or the whole system around getting working code into production was much, much more important, or a much better predictor of whether you could deliver value to a customer than how well you could write your code. And that progress that we made, that development, is what made that possible. The thing that we don't often think about is that as an industry, software development had progressed to the point where we didn't care so much about the code. That wasn't the bottleneck. We had built tools on top of other tools, on top of frameworks, on top of things to make all of that so easy. So the processes that we were developing and the processes that we used to put that code in production were the important part. Now, the processes around this had been around well before the term DevOps was coined, but it was becoming increasingly clear that this was what we wanted to focus on if we wanted to deliver valuable software to customers. As everybody might have seen a thing like this. This is our standard kind of infinity symbol that we talk about with DevOps, where we do our idea generation or our planning, we build the code, we ship it out to production, and then we learn from what's in production and what people are doing with it, and then we go through that cycle. And DevOps is excuse me. DevOps is all about doing this as fast and reliably as possible, right? Getting stuff out production as quickly. So you've probably seen this, and it's very important. This is the good old DevOps infinity symbol. It also represents the fact that your project never, ever, ever, ever ends until somebody stops paying money for it. But I like to kind of flip that around a bit and just unwrap it. We're really talking about two parts. We're talking about the learning what we want to do and planning for it, and then the creating it and delivering it. Can you tell that I designed this slide and the Microsoft people designed the previous slide? So if we just pretend that the coding part is trivial for the moment, which is what I've been saying, we'll come back to that, and we just look at the outer bits here, this is kind of what we call the outer loop of DevOps, where we plan the work, we learn what we need to do and we plan the work, and then the coding bit happens, and then we deliver it into the hands of customers. So let's look at the top part of this first. So everyone agrees at this point, sure, that waterfall is terrible, and nobody should be doing waterfall development. We'll ignore the fact that that was never actually what waterfall was about. Waterfall was supposed to be iterative, but anyway. But we all agree that big upfront planning, followed by this long period of writing the code that you've decided you're going to write, followed by deploying it to production and realizing that most of it is wrong because it's not what they really wanted, even though it's what they asked for. We agree that that's bad. So we fixed this entirely without any problems by introducing Agile. So Agile solved that problem immediately, right? We realized that our backlogs could and should change. Right? We can't plan everything that we should do up front and expect it to be the same when we get into production. The problem here was that management really, really wanted us to tell them how much something was going to cost. And the easiest way to do that is to have a list of everything you're going to do and work out how many things of those you've done, and that's the percentage through your project you are, right? Very easy to measure. So we tried to measure things like velocity, right? How fast are we doing stuff? So how fast are we getting a ticket from one side of the board to the other side of the board? And that will tell us how well we're doing. Sure, we can add tickets, we can remove tickets, that's fine, but this is a measure that we can care about. But the key point here is, what is velocity? And velocity is not speed. Velocity is speed in a direction. And if you're going in the wrong direction, your velocity in the right direction is much less. So if you're going at 100 miles an hour in this direction, you're going less than 100 miles an hour in this direction, and you're getting further and further away from where you actually want to be. So how do we determine what direction we're going in? Well, determining what direction we're going in is dependent on that bottom part, the delivery. And that's where the other part of the outer loop comes in. If we're not delivering stuff to customers, we don't know whether it's the right stuff or not. We can do testing, we can do QA, but the real way to test it is to try it out for real. So at the other end of this outer loop is CI/CD, continuous integration, continuous deployment. You automate your builds, your tests, your deployments, and I can confidently say that implementing CI/CD is the best thing you can possibly do for a project that will lead to better delivery of better software. And I say that after 15 years of advising people how to do this and how to implement it. For relatively little effort, you can get so much more throughput, and that means you can deploy smaller pieces that you can react to when they're not exactly right. There are two elements to CI/CD that make it important. Has anybody heard of the power loom? So a loom is, and I'm going to betray my lack of knowledge here, a loom is one of those things where they make fabric and you have threads going this way and then a shuttle that you fire across in between, it threads between them, and then you hit some pedal and it flips them and you do that. So you're basically just sewing thread, right? So there was these automated threads, automated looms that were invented. So rather than having a whole a whole warehouse floor full of people manually operating these things to end up with fabric, you would have them automated, and there'd be one person standing at the top of the thing looking at them all, and if one broke down, they would rush down there and they would turn the thing off before it ruined too much fabric, and they would reset it. So you suddenly didn't need 100 people, you needed one in a warehouse. Super productive. The real power of the power loom, though, was not that automation. That automation had already been there. The power loom was invented by a guy called Sakichi Toyoda, and its real power was that it stopped the loom when something went wrong. Not that it was automated, that had already existed. But if something went wrong, it stopped and waited for somebody to come and correct it, and you wouldn't waste all of this thread and all of this fabric in the meantime. So an effective CI/CD pipeline, continuous integration, continuous deployment pipeline, will do this. It will stop anything bad from getting into production. That's why you have your automated tests, right? So the code you write is absolutely important, but being able to identify when the code is not going to work is incredibly important. And being able to do that in an automatic way is far more important. You may have heard the stats that they have on how costly it is to fix a bug that makes it all the way to production versus how costly it is to fix it if it's in your editor. And it's orders of magnitude cheaper to fix it earlier. This is where we get this whole idea of shifting left in DevOps that we talk about. The earlier you can figure out problems, the cheaper they are to fix. So that's what the power loom did, and that's what a good CI/CD pipeline did. So at best, this makes sure that nothing bad is going to get in production. No broken code's going to get into production. Production doesn't go down. Your company can keep making money. But what I can't tell you is whether the code that is in production, that runs, is actually providing value to the customer. Like, is it really solving the problem? And as developers, we don't think about that a lot. We pretty much write the code that we're told to write, and it's somebody else's decision about whether that code solves the need, right? So the other thing you need in your outer loop with DevOps is the ability to test this, to test in production. Now, this closes the loop nicely because you're deploying, but by putting it in production, you're also learning whether what you have written is what they want, is what the person wants. So the second reason that CI/CD is powerful is it allows you to put stuff in the hands of customers who can tell you whether it's the right thing you've built really, really quickly and really easily. It lets you test your features faster. Now, if you're still looking at this test in production thing, thinking, that's pretty funny, I've got a surprise for you. Every piece of code you've ever put in production is being tested in production. Right? You may have an amazing staging environment or QA environment. It's not production. You can get close, but there is absolutely nothing that beats real people using the real application in the real world with real data. You cannot fake that. Everybody is testing in production. It's just whether you have another environment beforehand to catch them things too. So everybody is testing in production. The key here is to embrace that and to realize that when something is in production, that is a good opportunity to find out whether it's the right thing to do. And if you've just spent 6 months building it and it turns out it's the wrong thing to do, then you've wasted 6 months. If you can put that out in an hour or get somebody to test it in production by turning on a feature flag and tell you whether it's right or not, and if it's not, turn the flag off and keep working. Super, super beneficial for the delivery of software. Far more beneficial than whether your loop is fast. Right? So this whole outer loop, this learn, plan, deliver, and so on, the whole purpose of this is to be able to quickly adjust and change what we're doing. Right? If you can write the most beautiful, cleanest code, incredibly performant code, but if it is code that your customers don't want or it doesn't solve their problems, then you have created rubbish, like trash. You've created garbage, beautiful, elegant, performant garbage. The code itself, wonderful, but it is just a detail. There are a million ways to implement what you implemented. But if you've done the wrong thing, then you have completely scuttled the project, right? Pictured here, by the way, this is a real photo from when I was in government. That's the projects that I worked on. All right, so let's look, and we'll be fair here. So far, I've kind of subtly shat on writing code and said that writing code is not that important, but it is important, and it is what we do day to day as software engineers, right? We write the code. The thing that I don't love about this DevOps image that we talk about all the time is that we've got these 4 different segments that are all presented as exactly equal, and the build one, which is the actually putting code on a page to solve the problem, the solving the problem, like the mechanics, the actual working on it and stuff, is this little thing down here. It's like we're saying we do this massive planning and we make sure we're getting everything right and we do some stuff. And then we give it to people and then we learn from what they're doing. And we just completely gloss over this whole inner loop. So I want to talk about this inner loop, right? Again, let's expand it into this beautiful hand-drawn image. There's this whole build, test, deploy loop that we do as developers day to day. So that outer loop of planning the work and then deploying it once it's done, that's the outer loop of DevOps. The inner loop of DevOps is about making our lives easier and making developers more productive. So how can you write code more efficiently? How can you change direction more efficiently? So yes, important to get the stuff out the door, but we don't think about optimizing that inner loop very much. You use the tools that you use. Maybe you get a choice, maybe you get told what tools you're going to use. It is just as important to optimize for that inner loop. And by that, I mean better tooling, so tools that actually help you do your job rather than ones that fight against you. And the ability, this is super important, to easily context switch. We talk about being able to change direction with Agile. Is something more important going to come down the line? Is there an urgent bug that you need to fix? If you can't context switch, if you can't switch to do that work, that is extremely damaging to how you're getting software out the door. I'd be remiss if I didn't mention branching strategies as well. I don't want to go into too much detail, but good branching strategies can be incredibly beneficial for writing efficient code where you can change direction and change what you're doing. If you're working on a feature and you're able to just switch to another branch and work on that other feature and then come back to this one, super beneficial. It's worth investing in. That's an entire other talk, so I'm going to skip that one. The things that are coming up in the industry that are really powerful in terms of context switching are things like ephemeral dev environments. So we talk about infrastructure as code a lot in DevOps, where your staging, test, production environments are these environments that you can create and deploy to, and then when you need to deploy a new version, you create a brand new one and you deploy to it and tear down the old one. And everything you need to run your application is defined alongside the code. It's beautiful. It's so, it gives you so much trust in what that environment looks like. But then everybody has a different laptop in their, in their cubicle. We don't really do that anymore. But everybody has a different laptop with different stuff installed, and I have different versions of, dependencies on my machine. Ephemeral dev environments are the idea that for a project, you have a development environment. And if you need to change projects, you just put that one aside and you use one of those dev environments created specifically for the purpose of that new environment. It means that any dependencies that project has, you don't need to install on your machine anymore. They live in that environment. It's like a virtual machine that sits in the cloud that you can turn on and off as required. I'm trying not to product pitch, so marketing slide. GitHub Codespaces is the one that we do at GitHub. Gitpod, I think, has an alternative as well, where they do the same kind of thing. If you want to run them locally as well, just using dev containers is the technology that powers both of these. And it means that alongside your code, you are able to define what is required to develop against that code. And you don't need to install stuff or change direction really dramatically between projects. To put it in perspective, though, we don't like using the word dog food. We drink our own champagne at GitHub, that's what we say. We started using Codespaces well before it became a public offering, essentially. So github.com is like a 7 gig on-disk monolith Ruby application. It used to take, the better part of a week to onboard somebody. A new developer came into GitHub, and to be able to commit code that would actually eventually get into production, it'd take the better part of a week at best, right? When we started using code spaces and then started using other features in code spaces like pre-builds, that has come down now where a new developer can come into GitHub with any laptop in the world, although they get given a MacBook, and they can start writing code against the code base that they can compile and debug and push to production. And it will be ready for them to debug in less than 15 seconds. Which also means that if somebody tells you, hey, I want you to explore this idea and maybe try some stuff, you spin up a code space, try some stuff, completely ruin the code base, not an issue, and then when you're done, you're like, okay, cool, and you just delete the code space and you're back to where you were. It also means if you need to go onto a different project that has an entirely different software stack, you can just throw that one away for the moment and start a new one. Huge benefits to doing this, whether you do it with code spaces or an alternative. Massively beneficial. Oh, if you need a full machine to do that, by the way, so code spaces is VS Code that kind of runs in the cloud. If you need a full Windows machine to do it, Microsoft has dev boxes, which is the same idea but with a Windows machine. A little bit more complicated, but same principle. For me, though, the best way to handle changes really, really easily, and this is going right back to being a developer, is to architect for change. And I apologize for using the word architect as a verb there. Is it a verb? Yeah. I don't like that either. I'm very ashamed of myself. But it's the best way to put this forward. So being able to use techniques like dependency injection and inversion of control and things like feature flags and so on allow you to be able to write new implementations of functions or functionality and even deploy it out to production without that running. So as long as the thing compiles, it can be deployed to production, but it's just that code never runs unless you point it at the new implementation. This is an incredible technique for being able to change direction. You can be 3/4 of the way through a really complicated change and then got told to drop that and do something else, and it's not a big deal. You don't have to work out how to unwind all of the stuff that you've done over the last week. So being able to try a new implementation by turning on a feature flag for 1 or 2 people in production is incredibly useful as well. Super worth looking at that as well. Ultimately, one thing that can really benefit you as a development team and even as a company is being able to optimize for this context switching. So ephemeral environments, great branching strategies, having a good architecture that allows you to try things and then throw them away without it being a big deal. The combination of those things gives you the ability to start new work, change direction, do different work, and it's not a massive pain every time you get asked to change. Because the problem is, if it's hard to change direction as a dev team, so if somebody tells you to drop what you're doing and do something else, if it's really hard to do that, one of 2 things happens. Either you avoid changing direction. If somebody tells you, hey, that feature that you're 3/4 of the way through, we're not going to need that anymore, you're like, you've committed to that, we're still going to build it, you need to go through the change advisory board, you need to do a change request and go through all this process because we want to make it hard for you to change your mind because it's so hard for us. You avoid making change, and that's what we learned with Waterfall. You want to be able to make change, otherwise you're just wasting your time. So that's one option. You avoid changing direction, or you never get anything done because you're constantly changing direction, right? Both of these things are far more damaging to a software project than an inefficient loop or some, bad code. Right? I have had these happen, both of those scenarios where you avoid changing direction and you just build things that people don't want. And I've been in organizations where you do the opposite. You can't get anything out the door because people are constantly changing your priorities. Try to avoid both of those if you have the ability. Realistically, though, as developers, sometimes we don't get that choice. And I suggested this before, right? Sometimes we are told, here is your backlog. You pick things off the leftmost column and you do them and you move them to the right column, the rightmost column, right? And so to some extent, as developers, we kind of have to do that and trust that that is in the best interest of the organization. Everything else is above our pay grade. And a lot of that comes down to team dynamics and to management. So who here actually no, before I ask that question, who here is sitting very physically close to their boss right now? Okay, cool. You two are exempt from the next question. Who here has worked for a manager who is terrible, right? Okay, all right. No. We just assume those two, they didn't put their hand up. For me, a bad manager is somebody who prevents me from doing the work that I've been hired to do. And that can happen in a number of ways, right? It's either doing work that you shouldn't be doing, like burning time, going and speaking to other departments to get them to do some stuff that you absolutely need to be doing to do your job, or to going to meetings, or to filling out forms that are completely pointless that nobody ever reads, that kind of stuff. It could be doing the wrong feature, implementing the wrong feature because they're like, no, we committed to this, we're going to do it. You as a developer, you're hired to write code, like to implement these things, right? And there's a lot that we do as developers that doesn't contribute to that goal. I once had a manager who called a meeting at the start of a project to decide whether the database tables were going to be plural or singular in the database, right? That was a 2-hour meeting with everyone in the development team. His position at the time was that they should be singular. Save space, the table name matches the class name in the code, right? So it's a customer and then the table is called customer, matches, makes sense. There was one other developer, senior developer on the team at the time, who had the vehement opposite opinion, right? It should be plural because you have a table full of customers, so it should be a customers table, right? They argued for 2 hours. My opinion, and the opinion of basically everyone else there, was it doesn't matter. Who cares? Like, why are we here arguing about this thing that is completely pointless? I genuinely believe that meeting only finished because that senior developer realized that this could go on forever and he'd already lost the will to live, so he just conceded, and nobody ever talked about it again. It got implemented, it got done. So that's a bad manager. Like, that's somebody who wastes your time with stuff that doesn't actually matter. It's not always the manager's fault though, right? Who here has worked in an organization that I alluded to before where the direction of what you're supposed to be doing changes so often that you can't actually deliver anything, right? You write half the stuff and then you're told to drop it and do something else. Yeah, me too. The only way we got things done was to subversively ignore requests, or we had a fantastic manager who I'll talk about in a sec who protected us from that kind of stuff. Poor management, though, is ultimately super demoralizing and directly impacts how well you can deliver software. So much so that in 1944, the Office of Strategic Services in the US, which later became the CIA, they wrote a handbook on how to sabotage organizations from the inside with management techniques. Some examples, I'm going to read out some examples because they're great. Insist on doing everything through channels and never permit shortcuts to be taken in order to expedite decisions. When possible, refer all matters to committees for further study and consideration. Attempt to make the committees as large as possible, never less than 5. Refer back to matters decided upon the last meeting and attempt to reopen the questions on the advisability of that decision. Insist on perfect work in relatively unimportant products and send back for refinishing those that have the least flaw. Approve other defective parts whose flaws are not visible to the naked eye. There's one more as well, which is hold conferences when there's more critical work to be done, but I think that one's fine. But the rest of it, like, does that sound familiar to some of the people who have worked in bad environments? Right? This was a wartime strategy to deliberately sabotage an organization from the inside, and we see it every day in organizations that are supposed to be making money, right? But it's not just the managers and the management themselves, it's also the process. So the processes shouldn't get in the way either. This is does anybody know what this is? The SAFE framework, I think, something like that. You'd think I would have written it in the slide notes, wouldn't you? But this is an example of the kind of process that we follow while we're trying to write software in an agile way efficiently, right? A lot of it is management, but a lot of it is poor process that just gets added to and hampers our progress. Another example, this is a guy named Albert Goering, who's the brother of Hermann Goering, who was the founder of the Gestapo. Bad people, obviously. But Albert, it's fair to say, didn't really like the Nazi Party. In 1939, he became the export manager for Skoda, like the automobile vehicle company. So this is in the middle of the war. He famously forged his brother's signature to get Jews out of Czechoslovakia when Germany invaded. But there's one thing that wasn't as well known about this guy, is that apparently, excuse me, apparently he used some of those same poor management techniques inside the company in order to hamper the production of vehicles that could be used by Germany during the war. So he deliberately used some of these poor management techniques to defeat the Nazis, right? In case you're wondering how effective bad management is. On the flip side, though, there are good managers. So I had a manager at a company. We never called him this to his face, but he found out about it later. We called him the shit umbrella, which sounds horrible, but it was a compliment, right? We realized after he left just how much stuff he was protecting us from above. And the reason I realized it was that I was given the umbrella when he left. So I saw what his real skill was, which was protecting the development team from all the stuff that came from above that hampered their work. So he was really effective because he was also a developer, but also a good manager. We have this tendency to have development and management in separate silos that are separated by these walls, and they don't know how to talk to each other, and their communication is really poor. So everybody gets upset with everybody else, and stuff doesn't happen, right? Now, typically this is a problem and a barrier. So if you can find somebody who knows how to do that translation between the two languages, to understand what management actually wants and understand what the customers actually want, and also understand what the developers need and what they need to care about. That is hugely beneficial for a dev team. Good management that keeps people focused on the tasks they should be doing, and processes that do not get in the way are much more important to developing and delivering real software that solves the people's real problems, and then again, using the latest syntactic sugar or new version, excuse me, new version of .NET or Node or whatever. Sorry, I'm just going to drink. So these are the three things we talked about. Broadly, we have the outer loop stuff. Good CI to CD, good planning, being able to change direction, and being allowed to decide what work is important and so on. The inner loop of everyday work. How easy is it for you as a developer to do your work? There's some awesome research by Gene Kim that's worth looking at called the 5 Ideals. Absolutely worth looking into that. He talks about that in great depth. So developer productivity and developer experience. And then the whole broader management side of it as well. And these are broad categories. But as a developer, somebody whose job is to write code, what can you do about most of these? Do you just put your head down, write code, and ignore it all because you don't have the control over a lot of that stuff? What I'm suggesting is that yes, it's important to write good code because it needs to be maintained, it needs to be readable, but if you look around the room, you are surrounded by other developers who can also write that code. If you have a broader view of what is important in an organization for delivering actual valuable software, you are going to be much more valuable to a company than somebody who just sits and writes the code blindly to solve the problem. There was some great advice I got early in my career from somebody which was, find out how your company makes money, and then find out how the work you do contributes to that making of money. If you don't know the answer to that, then you don't know how you're providing value to that company. So broaden what you're looking at a little bit more. If you have the ability, optimize for the developers in your organization. Make it easy for them to change direction and write better code with better tools. Optimize for the delivery of that into production as well, and learning what customers actually want and need. So embrace the code, right? Write great code. Languages and language features are amazing. You should keep looking into that. They're beautiful, it's fun, we enjoy it, but realize that in the big picture of delivering software to customers, that your code is just a detail. Thank you.
Big round of applause for Damian. We have time for probably one question.
Or like heaps more questions later on. I'll be around. Yeah.
Can I work for you?
Can you work for us? Yes, as long as I don't give a time limit on that. We are in a hiring freeze right at the moment, but if you do want to work for GitHub, careers.github.com is the place to hang out.
Yes, thank you. Another round of applause for Damian, please.